second. Let me start up the clock. Hey, this is Steven from Legit Tech Tutorials, and welcome back to my product development series. We're back working on the CNC Plasma table. This is CNC Plasma table video number 4, and today we are going to be working on the so this would be the X, this would be the Y, this would be the Z. So it's not exactly set up how we have it here. So this is the X, this is the Y, and the Z is up, right? Actually, now that I'm thinking about it, we have this thing all messed up. Let me see if I could overall rotate. Can I rotate overall? Let me see if I could rotate one of them and see if it will allow me to rotate. There we go. X, Y, perfect. So this is our orientation. X, Y, Z. X goes along this way, Y goes along this way, Z is up. So this is our overall, something messed up here. This thing is not perfect. Anyways, yeah, so this is our overall rotation. So now what we're going to work on is we're going to work on the Y gantry that also obviously moves the torch along the X gantry. So basically the gantry that goes on here. And so one of the ideas, because I don't have anything that I can use to bend tubing, was to get some rectangular tubing and then cut the bottom out of it, so that we have kind of like a channel that goes over this tubing. So let's go ahead and take a look at what size of tubing that would need to be. Let's go ahead, use the inspect. Okay, so this is what? Oh, 0.2 feet. So that's 2.5 inches. So 2.5 inches, and so we're going to need to have 608 bearing. Let me see if I can find the carriages again on here on my second screen. But basically, if you remember, it was just some not necessarily channel, but it's just some box tube, and then they cut the bottom out of it for it to ride on there. Let me see if I can find it. Okay, so this one, you could also do this one. I like it to be as quick to put together as possible. Obviously the box tubing would be way easier. I could do a kit on the plasma after. You know, I could expand on it after, but the idea is to build it as quick as possible. Then if I have to do different gantries, then that's fine. Because the other thing is also we want enough space to have the to even have maybe so maybe some tall box tubing, or even square tubing. Square tubing would even be fine. So what I'm thinking of is the carriage go up to about here, halfway. Bearings right along the top here, right? Right along the top, maybe quarter of this guy. So it goes about halfway down, and the first quarter has the bearings in it, and then the rest of it will have the motor that will be on the side with a hole, right? The hole cut on it, and then you have you know, the bolt holes for that laid out, and that'll all be cut on the mill. So that should be pretty easy to take care of. I mean, obviously it would be way easier to do on the water jet, to kind of cut out some things like this and then just bolt them together. But we don't have the plasma yet, so we could use some box tubing in the meantime. And something kind of like this. Or here's another way. This goes inside the tube. Chain setup. Chain sprocket. It's another way. This one's also another way. Nobody seems to be doing it out of box 2. Okay. I can't find that one. So let's just move forward with it. Alright, so here, so with that you have 608 ZZ ball bearings. 608 ZZ ball bearings dimensions. 608 ZZs are generally used on what is it called, on skateboard bearings. So outside diameter is 22 and then bore diameter is 8, so it's technically 11 millimeters from the inside to the outside. So let's go ahead and start another design here. So first we're going to have a ball bearing here, just so we can lay this out so this logically works. So here this is 22 millimeters, and then the inside is 8 millimeters. And this is 7 millimeters tall. 7 millimeters tall. This is a bearing. 608Z bearing. And so I'm thinking with this guy, it's going to have 1, 2, maybe 2 on the top, and then 2 on the other side. So 1, 2, 3, 4, 5, 6. Set on 6 on one side, so it's 12 on the other side as well. So there it is, 608 ZZ ball bearings. And now let's go ahead and create a layout. And then this I'm going to call the carriage. Make sure this is saved. New design. I'm going to call this carriage layout. Okay, and basically what I'm going to put in there, and then I'm going to save as this one. I'm going to file, save, and then this is going to be the short assembly here, and I'll save the short assembly. Basically I'm just going to turn off one of the beams on there. Well, this is technically a sub-assembly, but yeah, you get the idea. Okay, so CNC plasma table carriage. How long is this one? It doesn't have to be long. This is fine. 3 feet is fine. Okay. And then 1. Two. 3, 4, 5, 6. Okay, so 2 on the top, 2 on the bottom, 2 on the side, and 2 on the other side. So obviously we're not going to have one on the bottom holding it down, but I'm not too worried about that with the weight of the machine. And then also we don't want it to be where it's racking. So we're gonna have very low center of gravity, where basically that top bar is probably gonna be right on top of this thing, because this thing's gonna be riding about what? So it would be the 1/8 inch bar. So it's probably the tube is gonna be 1/8 inch wall, and then you have at least 11 millimeters, and the bearing's gonna be on top. So it's gonna have maybe maybe 7 millimeters of clearance, which is 7 millimeters to inches. So it's going to ride about 1/4 of an inch away from this guy. So it's going to have pretty low center of gravity, so it should ride pretty good. Alright, and then we need a pin or something, which basically these guys are going to be just have a pin going through it, and it's going to be welded onto the side with 2 nuts. So you have 2 nuts, pin going through, bearing pushed inside. Or a bolt. We have to find a bolt that has an 8 millimeter shoulder on it, right? And goes through something to hold this thing on there. But because this, we don't want to have any slack on it, because we don't want this guy to move, because this is where all our precision is going to be. Because if this is nice and tight, this other side is going to be also nice and tight, and we would only need 1 motor, even though we're probably going to need multiple. Okay, so let's look at what we need here. And that piece is going to have to be here, because we're going to have to bring it in for the carriage. Okay. So let's go ahead and position one of these so that you guys can see what I'm talking about here. So this goes here like that. Rides along the side. So I'm thinking, obviously too close. Yeah, whatever. I'm thinking probably ride somewhere up here about the first 1/4. So this is going to go down to about here. So if that's the case, it's probably, well, we need the motor to fit in there. And so this first set, let me see what it is on eBay. eBay. Here's a gerbil NEMA 23 kit with some decent sized motors, 3 limit switches, 4 motor drivers, Arduino Uno, small cable, obviously you need a way bigger one than that. Also, you see there's no connector on there. That might be a problem, so that needs to go onto the motherboard. No connectors on the NEMA 23s. But I don't think we need to go any bigger than NEMA 23. NEMA 23 dimensions. Okay, so here's a is this a NEMA 23? Okay, so the NEMA 23 motor is 2.3 inches around or down the side. So DD here, DD motor size, NEMA 23. Do we have any other dimensions? So here's an example. This will vary depending on how much torque you have, but this is mainly what we're looking at. So it needs to be at least 57 millimeters, but 57 millimeters is pretty big. It's 2 inches. Okay, so this is going to have to be tall extrusion. So I'm saying it would probably have to be 3 by 3. So maybe this one. So maybe let's modify this. And I'm thinking maybe 6 inches wide, somewhere around there. Please don't crash. Yeah, it crashed. Something happened with Fusion on their last update, most likely. Everything should have been saved for the most part, but so this is still there. That's fine. No, that's okay. There's nothing in here now, but who cares? Okay, so let's go to model on this one. Let's change this to be 6 inches. 6 inches. Okay. We'll save that. Oops. Carriage layout. So let's drop one of these. One of these. And then a whole bunch of bearings, but we'll go there in a second. Okay, so now the question is, no, this is too tight. This would have to be really big. Maybe. Let me see. So this is going to ride about half. And then we need enough space here at the top so that the NEMA could go in here and it could ride on this thing. So let's see what this space is. Oops. 1/8 of an inch. Let's change this guy to millimeters so we could not have to do all the conversions all the time. 3.175, and the inside of the bearing is so this 11 and it was 3, right? 3. Okay. It's probably too small. Okay, so we're gonna have to look for bigger. But obviously, another problem is that this has to at least fit the NEMA back here, and this is 3.5 by 3.5. So let's go back here, 1/8 wall. So let's say that this is maybe 3.5 by 3.5. Oh my god, I'm about to freak out. Fusion's kinda unusable today. I don't know what the problem with Fusion is. Normally it's not as bad. There we go. Maybe this crap. Okay, so that's fine. That's bigger. Layout, carriage assembly. Don't crash. Okay. Okay. Move. Alright, so this, again, is going to be somewhere around here. Now this is what we're talking about here. Here's the sidewall. About 3/8. Yeah, well, exactly 3/8 of an inch. Okay. So let's change this again to millimeters. Obviously, now that I think about it, this thing is way too far from the... because obviously those bearings need to ride on the top here. And those bearings are probably going to have to be inside because we need enough space for the pulley to go in there. So this is 9 millimeters. That's perfect. Should be able to ride on there perfectly. Okay. So obviously what we need is this. So let's go ahead and draw on the side of this thing to figure out how big this NEMA has to be here, which is at least 57 by 57. So let's just say that it's at this corner. Obviously it's not. And then this center circle is how big? So its center shaft is 9.5 millimeters. Well, overall 10 millimeters. Okay. Obviously, we do need to give it a little bit of room. So let's see. Let's just do dimension. Oh crap, I left the sketch. Probably gonna have to delete this. Okay, so let's draw just a regular square somewhere here in the middle. Oops. Oh crap, I don't want to do that. Get away. Okay. Dimension. This is 57. This is 57. Okay. Distance from here to here, I'm going to say at least 1/4 inch. Oh, sorry, not quarter. At least half, maybe half an inch. Because we do have that, let's do 1/4 inch. Because we have to clear the 1/8 inch wall at the top. Okay, so let's go ahead and make sure that it's equal distances on both sides. Let's draw side lines here and then just set it to be parallel to the equal. Just put a point in the center. Let's have it oh. Midpoint. I never use this symmetrical. Well, this should be it's like 47. Somewhere on there. Okay. I did leave the sketch again. Whatever. I just need to see it. Okay. So the problem with that is that this thing is going to be way far away. So maybe we might, for this particular setup, need to use some smaller stepper motors. Just regular NEMA 17s. Let's see. Or we'll have to have a piece go across here that holds the bearings in here with little spacers on there, 2 little nuts or whatever that hold that thing square in the center, which is not that bad of an idea. Because again, also this guy needs to go up and over the bearing in order to fit on there. So let me show you what I mean there. Let me see if I can change the transparency a little bit. Change transparency. I've never changed transparency on here before. Appearance, I guess. Okay, change plastic. Acrylic clear. There we go. Okay. So let's just say that this is the case. So you would have a bearing here that would ride on this thing, and then it would go up and down and across, right? Through this thing here. So I do kind of like this this big of a piece, but it is really big. This could be really more beneficial if it was up more towards the top. Maybe even if I wasn't going through as many stepper motors as I needed to, but yeah. So another thing is logistically, how would the belt go through here? Because usually you have the belt coming up here, up and over. So this guy would be, the belt would be running on the right side here. And also, how long is the shaft? Shaft on this guy is only 20 plus a little bit. This is minus 20 millimeters, minus 20 millimeters. So this is barely going over it. Oh, 24. It's 24 millimeters. Let's just say 24 millimeters. Minus 24 millimeters. Okay, so belt goes right across here. Pulley bearings are in the middle. So the thing rides. I think it'll work pretty well. But yeah, so we're gonna have to have a shaft go through here with the bearings. So if I go back to this same drawing, if I wanted to propagate this piece through, did I do it? Project. Okay. And I'm going to draw a circle. So let's just draw a line. I'm going to say it's about you know, one third across here. Just 2 bearings to support that weight. I'm going to say this is, so it's 6 inches, so we need to divide that into 3 portions. Actually just a quarter, so let's say 2 inches. By 2 inches. I think even that might be extreme. Wait, what? What am I doing the drawing on? Ah, no. There we go. Okay. I'm going to go a little bit over because of the problems with fusion. That's 1.5 inch. Let's do 1 inch. Okay. So now this is a 22 millimeter circle. Nice. This is 8 millimeters. This is 8 millimeters. Wait, what? Oh no, this is not the right spot. Project. Okay. This is supposed to be this. There we go. Collinear. There we go. There we go. So it looks kind of like that. And then the bearings would be riding on that guy. So we would have one bearing here, another bearing here. But then we kind of want these shackles kind of closer. But that's okay, because generally you want quite a bit of contact on the shaft here. So when you put that shaft in there, you want these guys to be kind of close, but we want it to also have kind of a wide footprint, and so we don't want to put so many bearings on there. But this is looking pretty good. So then we would cut the bottom out of this piece here, cut this out, and slot there, you know, plasma or whatever, handheld plasma or whatnot, whatever is the quickest way of cutting it. Let's cut the bottom out of the box. You put it on the mill, and then drill these perfectly on the mill, perfectly where they need to be. These holes. Press a rod in there or whatever. Probably a bolt, because then we would need to put some nuts on here to hold the bearing perfectly in center. And if the bearing breaks, we need to be able to replace the bearing. And then this guy, we would have obviously a what's it called? A 17 tooth or whatever tooth on there, and then we would have a belt that would run along the length here towards a third on the inside here, and this guy would pick it up. Maybe even have this guy on the back side so that it's further away from the flames and stuff. And because this is the way it's riding, we could even have like a little piece of plastic or something over top of the belt, or something. I'm not too worried about it damaging the belt, but yeah. So this guy rides on top. This guy would be really nice and polished. The bearing rides on top, 2 bearings, and then on the sides we would have a bearing here and also a bearing here that ride, you know, obviously perpendicular to these bearings here, and they'd ride on the side here as they go down. And then that way we have this half section here to put the ribs in, and then basically just move this guy so this guy isn't in the way while we drop the ribs in there. So that's the idea. This guy would go up and down, right up and down with these bearings. So let's put a bearing in there really quick before we call this video good. So let's do a joint. Somewhere around there. There you go. And this surface would be, you know, driven on this surface, go back and forth, etc. So again, another thing that I'm kind of worried about is the stresses on this guy. You know, how well are these pins going to handle the stresses? These threaded pins, most likely. Or maybe in this case threaded, and then this is a soft, this side here is like flat or whatever. Anyways, so that is pretty much it. We're at 39 minutes, so let's cut it here. Alright, so this has been Steven from Legit Tech Tutorials. I thank you guys for watching. If you like this video, please subscribe for more videos like in this series or series as well. See you guys in my next video. Thanks for watching. Take it easy. Peace.